Class today we're going to take a look at what we call mixed expressions and complex fractions. So let's write each mixed expression as a rational expression. Example 1. If I had 2 plus 5 over x. Now remember, in order to add or subtract fractions, they must first of all have the same denominator. Now remember, this 2 has a denominator of 1. My least common denominator for these two fractions is x. So I'm going to rewrite this so that both of them have a denominator of x. If you recall, when you did regular fractions, 1 times what gives me x? It would be x. You take that and multiply it by 2, you get a 2x. This fraction already has a denominator of x, so the numerator remains the same. They have the same denominator of x, so we'll bring that denominator over, add our numerators. I get 2x plus 5. 2x and 5 are unlike terms, so that is all that I can do. You cannot cancel out these x's, class, because that's an expression, so your answer is 2x plus 5, all divided by x. Example 2. If I had 6y over 4y plus 8, and I want to add to it 5y. Again, the least common denominator here is 4y plus 8. So I'm going to rewrite this so that both of them will have the same denominator of 4y plus 8. Well, this first fraction already has the LCD of 4y plus 8, so that numerator remains the same. To get my new numerator here, all I have to do is take the 5y and multiply times that denominator, so I'll have 5y times 4y plus 8. As I simplify, I get 6y, and I'm going to put that all over this one denominator, and I'll factor that denominator as I do that. 4y and 8 have a GCF of 4, so that's 4 times the expression y plus 2. Here, as I simplify, 5y times 4y gives me 20y squared, and 5y times 8 gives me a positive 40y. As I combine like terms in my numerator, I get 20y squared. 6y and 40y are like terms. When I combine, I get 46y. That is over 4 times the expression y plus 2. And if you notice in my numerator, the 20y squared and the 46y have a GCF of 2y. So when I take 20y squared and divide it by 2y, so I will have 2y times 2 goes into 20 tens, so I'll have a 10y plus 2 goes into 46, 23, so I have a 23. That is over 4 times y plus 2. And 2 and 4 have a GCF of 2, so I can divide 2 into 4 and get 2. So I get an answer of, in my numerator, I have y times the expression 10y plus 23. In my denominator, I'll have 2 times the expression y plus 2. Example 3. Some new instructions. We're going to simplify each expression. So for example 3, I have 2 and 1/3. That's a fraction bar, so that's divided by 1 and 2/5. Well, this is called a complex fraction the way that it's written. So I'm going to take the mixed numbers and write them as improper fractions. Remember to do that. Multiply 3 times 2, I get 6, plus 1, that gives me 7. So what I have is 7/3. I'm going to write this in a form that we understand. The fraction bar indicates division, so I'm going to use this division symbol. 5 times 1 gives me 5, plus 2 gives me 7, so that gives me 7/5. Now remember your rules. To divide by 7/5, you're going to multiply by its reciprocal. The reciprocal of 7/5 is 5/7. I can use some cancellation. These 7s will cancel. So I get 5/3. So I can leave my answer as 5/3, or I can write my answer as 1 2/3. Example 4. If I had g to the third h, and that is divided by m, and then I'm going to take that and divide it by g h to the third, and that is over m squared. This is equal to, again, this is a fraction bar, it indicates division, so I have g to the third h over m. I'm going to write it in a form that we understand first. Remember, to divide by this fraction, you're going to multiply by its reciprocal. Now let's see if we can use some cancellation. As I look at this, I have an m squared in my numerator, a m to the first in my denominator, and if you remember your rules, when we divide like basis, we're going to subtract exponents. So I'm going to cancel here and get m. When I look at my g, I've got a 3, I have a 1, so I'll end up with g to the second. Now with my h, so I won't have to worry about negative exponents, the greatest exponent for my variable h is down here in my denominator. So when I divide this h into this h to the third, I'm going to get h to the second. So what I have left is g squared m in my numerator, and in my denominator I have h to the second. Example 5. X plus 7 divided by 4, and I'm taking that and dividing it by x squared minus 49, and that is over 10. This becomes x plus 7 over 4. I've already said that is division, so to divide by this, I'm going to multiply by its reciprocal. So I'm going to write the reciprocal of this, so that becomes 10 over. This is called the difference of two squares, so that means we need to factor it, and its factored form is the binomial x plus minus 7 times the binomial x plus 7. You notice we can do some cancellation. The x plus 7s will cancel out, and if you notice, 4 and 10 have a GCF of 2, so 4 divided by 2 is 2, 10 divided by 2 is 5. In my numerator, I notice that I have a 5. In my denominator, I have 2 times the expression x minus 7. You may leave that denominator in that form, or you may multiply it out. It's according to what your teacher instructs you to do. Example 6. For example 6, x plus 4 by x minus 1, and that is divided by x squared plus 6x plus 8 over 2x minus 2. This is equal to x plus 4 over x minus 1 times the reciprocal of this. And I won't confuse you, so this time I'm just going to write it and then I'll go back and do the factoring. So what I have here is x plus 4 over x minus 1 times that binomial. 2x and 2 have a GCF of 2, so I'm going to factor out a 2. In my denominator for that trinomial, ask yourself, what two numbers can I multiply and get 8, combine and get 6? So I'll have an x plus 4 and an x plus 2. Now as I look at this, I can do some cancellation. I can cancel out the binomials x plus 4. I can also cancel out the binomials x minus 1. And if you notice, in my numerator, I have a 2 left. And in my denominator, I have an x plus 2. Now don't get excited and think you can cancel out those 2's, because you can't, because that is an expression. So your final answer is 2 over x plus 2. Example 7. If I had the expression n squared plus 4n minus 21, and it is divided by n squared minus 9n plus 18, and all of that is divided by n squared plus 3n minus 28 over n squared minus 10n plus 24. Now let's see what this is equal to. This is equal to, I need to factor this numerator. I need two numbers I can multiply and get a negative 21, combine, get a positive 4. The greatest factor needs to be positive, so I'll have an n plus 7 times n minus 3. In my denominator, I need two numbers I can multiply and get a positive 18, combine, get a negative 9. Both numbers needs to be negative, so I'll have an n minus 3 times a n minus 6. I am dividing by this fraction, which means I'm going to multiply by its reciprocal. So this will go to my numerator. Two numbers I can multiply, get a positive 24, combine, get a negative 10. I would have a negative 6 and a negative 4. This will go down to my denominator. Two numbers I can multiply, get a negative 28, combine and get a positive 3. I would have an n plus 7 times a n minus 4. Now I'll check to see if I can do some cancellation. I notice that I have the binomial n plus 7 in my numerator, n plus 7 in my denominator. I can cancel those. I also notice that I have an n minus 6 in my numerator, n minus 6 in my denominator. I can cancel those. I have an n minus 3 in my numerator, n minus 3 in my denominator. Cancel. I have an n minus 4 in my numerator, n minus 4 in my denominator. Cancel. So I end up with an answer of 1. Example 8. On example 8, if I had x squared minus 9x, and that is over x squared plus 7x plus 10, and I'm going to take that and divide it by x squared plus 5x over x squared plus x minus 2. So this is going to be equal to, in my numerator, x squared and 9x have a GCF of x, so I'll factor out an x and get x times the binomial x minus 9. That denominator, I need two numbers I can multiply, get 10, combine and get a positive 7, so I'll have an x plus 2 and an x plus 5. Again, this is a fraction bar. It indicates division. To divide by this, I'm going to multiply by its reciprocal. So this will go to my numerator as I factor it. I have an x plus 2 times an x minus 1. In my numerator, they have an x in common here, so that comes down to my denominator. Now as I look at this, I'll look to see if there's anything at all that I can cancel. I notice that I can cancel the x plus 2. I have an x here in my numerator, an x here in my denominator, so I can cancel out the x. I don't see where I can cancel out anything else, so my final answer is the binomial x minus 9 times the binomial x minus 1. And I have an x plus 5 term twice, so I can write it as the binomial x plus 5 squared.